Hey, what's up, everyone, and welcome back to another episode of Naked CTF. I'm Jono from OpenLearnSec, and in the Naked CTF series, I will attempt to compromise and own a server from HackTheBox. This is the first time I've tried this box. I've not solved it beforehand nor read anything about it. It's done one take with no editing, so this could be 30 minutes or it could be 3 hours. So let's go. Today we're going to be doing Sau, S-A-U. It's an easy Linux box. Let's grab the IP. We just launched it a few minutes ago. Should be up and running. And we'll use our shell macro CTF prep, CTF HDB SAU for the name, and then the IP address. And that should set everything up for us. Launch our tmux session. If I do echo IP, we're looking good. Come over to our notes in Obsidian. Open this up. And there is Sau. So we're going to grab that. I've updated my template that I've used for CTF exercises. Like I said, a little bit of progress each time. So just trying to optimize after each exercise, improve things a little bit. And I'm sure it's going to morph and change in the future. So let's go into the working directory. And let's get our recon. I keep saying enumeration, but I mean recon really. I've got to start using the right terminology, and off we go. So doing a full port scan and deep service discovery with extra verbose output. Straight away, it looks like we've got two services, 22 and 55555. Okay, interesting. So likely that's going to be SSH. And this, I got no idea. I can't think of any service off the top of my head that is running on port 55555. It's like a phone number out of a Hollywood movie. Yeah, so I've just, like I said, continued to update and improve things, try and optimize the workflow. So now we've got a section for Nmap, for enum for Linux and SMB, because that's really kind of the base recon that we want to do. If SMB or Samba or anything like that is present. And trying to get more detailed in my progressive notes as we go. So kind of have a list of what to try next. That's after first looking through the list of services and everything else. Once we get to a point where we do have a foothold by being able to exploit something or, take some credentials and gaining access that credentials that we might find in a share or somewhere along the way. Really just want to have a checkpoint, think things through, reconsider where we're at. And then once we get to Privesc is really thinking that through, because I've kind of had this issue a couple of times now where it comes to Privesc and spend a lot of time, trying to figure out how to attack Privesc. And it's been a little bit frustrating to say the least. Okay, so let's do, control, where do we go? Control B, page up. So we'll grab 222. Let's stick this in our notes. So interestingly, 80 and 8338 is filtered. Okay, good to know. So let's get this across. And then we've got 555. I might just exclude this fingerprint response. So this is basically Nmap NSE script saying, hey, I found this service. I don't know how to accurately fingerprint what it is. So I'm going to leave that data out of our notes. We've still got a copy in the raw output if we need it. So yeah. Let's make these notes a little bit bigger. We have quite a bit of wrapping. I'm trying to find a balance between screen real estate and text size and everything else. We'll make this bigger. And let's review. So we've got 22. OpenSSH 8.2p1. The SSH banner indicates that it's running on Ubuntu. Good to know. So we've already got an operating system roughly figured out. And then we go down into these two filtered ports. So this is where packets are being deliberately dropped. Nmap is able to detect that. So what that means is that there might be IP tables or something that is filtering the incoming request from an external perspective. But if we do get a foothold on the box, that we definitely want to look for additional services that might be running but are only available locally. And then we've got 55555, the 55s. So it's done some fingerprinting. Not a lot. Looks to be a HTTP server. Let's do curl IP. Well, let's do curl HTTP IP. Nope, nothing going to come there. So really all we can do at the moment is leave SSH alone until some type of credentials are surfaced. Casual browse of HTTP service running on the 55s. Instead of saying 55555, I'm just going to say 55s going forward. So let's do that. We'll grab the IP address. Here it is. Let's stick it in the web browser. See what happens. We might just turn on developer tools while we're here. Actually, let's just reload just so we can see. If we do need to open it up in Burp Suite, we've got that prepared. But I think just, for the initial recon and enumeration of this particular service, I like to just use the developer tools. Seems pretty straightforward. Now, it doesn't seem like anything's actually responding. So we go back to our notes. Unknown Synac. Bad request close /web. So it did find this /web location. It's not enforcing HTTPS, is it? Nope, can't even connect. Oh, sorry. This is where I'm going wrong. Already, not off to a good start. The reason that first request wasn't working is that it was trying to connect to port 80, which was a filtered port, and the connection never completes, so the browser just kind of hangs there. Okay, this looks like some kind of CTF specific application that's been built. Let's have a look at the original GET, which is here. So it redirected us to /web. Even though we went to the root, we got this 302, which is a redirect. And that's what Nmap found as well. So we made the request for /, and then we got the response, 302 found, and it gave us this location /web, that new URL. So then the browser went to that. And not many headers in the response, nothing really obvious. So there's no like server header that indicates whether it's like Apache or Nginx or anything like that. Seems fairly vanilla. And then we go out to these external websites, these CDN endpoints for things like Bootstrap and everything else. So let's poke around this app and see what it does. New basket. Create a basket to collect and inspect HTTP requests. We might just make a note while we're here. We possibly may want to do dir and file enumeration on this HTTP service. Let's just do this. Or try and organize the notes by service or endpoint. Okay, so we're a little bit cleaner. But let's poke around first. So by default, it's Got this V4AA63W. Basket V4AA63W. Your token is this. So let's just grab a copy of that. This is kind of our raw notes. Now that to me looks like could be base 64. I'm not quite sure. Anyway, open basket, whatever the hell that is. This basket is empty. Send requests to this address and they will appear here. Okay. Up here we've got refresh, auto refresh enabled, settings. What's this one? Responses, share basket, delete requests. So let's copy this URL. And it's saying send a request to it. Okay. Curl. Okay, so it kind of acts as like a stub for web requests. Headers. Okay. So whatever we send to that, it seems like we are going to have the HTTP request and then displayed on this page, right? So this is like maybe a tool for people who are building software and maybe they need something to just capture a HTTP request from their application, or they're testing like a webhook or something like that. Basket responses get 200 response body. Let's put OK in here. OK CTF. And I'm assuming what will happen is if we make another request, we'll get that response body back. Yeah, there we go. So I've used a tool similar to this. What is it called? Hook.sites? Not hookup sites. Yeah, webhook.site. This is a similar sort of service. So here you get a unique URL, and then you can send a request to it, and the request will appear here. It's really useful if you're building software and you just need like a generic way to capture HTTP requests. Like I said, maybe you're testing your own webhook, or you want to be able to examine the output from another service, and so you send the API or the webhook request here, and then you can kind of dig through it and browse the contents rather than having to spin up your own mock API service or endpoint or whatever it might be. So I did see, what's this button? Delete requests and then delete basket. Yeah, okay. So I did see this powered by request baskets, which I'm assuming, yeah, GitHub project. Yeah, still fairly actively developed. Commits in the last few months, even a month ago. Web service to collect arbitrary HTTP requests and inspect them via RESTful API or simple web UI. Strongly inspired ideas and design of Request Hub, etc., etc. And yeah, this is really cool. This actually is something that I might use in the future because, like I said, I normally use this webhook.site, but that's an external or public-facing service. So this is very interesting. So not super sure about this option. Only because my initial reaction is that they've deployed an open source project, right? Version 1.2.1. And my immediate kind of reaction is, well, maybe this has got a vulnerability. So in terms of things to try, we're using, what's it called? Request baskets v1 2.1, and we're going to check for vulnerability that might exist. Exploit. So let's have a look. First thing I do is check the GitHub releases page, see what they're up to. So 1.2.3, 1.2.1. So this is a couple of minor releases behind. And they only have one release. They don't have historical releases. And I think I've said this in another video. That always makes me... Oh no, here we go. So version 1, okay, let's go to the beginning. Version 1.0, 1.1, 1.2, 1.2.1, 1.2.1, 1.2.2, 1.2.3. Now, normally, if the version that is here in the CTF lab is behind, the latest version, but that was released September 19, 2022. Normally, if it's a vulnerable version, the maintainer will of the open source project will pull this release, right? So they'll delete this release. They might leave the tag in place, the actual Git tag, but they'll drop this release because they don't want people accidentally downloading a vulnerable version, right? So that's kind of, point number one that makes me a little bit concerned. There might not be a vulnerability in version 1.2.1. Second is, from 1.2.1 onwards, we have 1.2.2 and 1.2.3. And there's no mention of like a vulnerability being fixed. So if we look at the full change log, that's going to give us the diffs. Oh no, sorry, it's going to give us the commits. So looking at those commits, there's no like obvious commit that says, fix issue, fix security issue, or fix vulnerability. Let's have a look at 1.2.3. Merge pull request, jQuery, updated, yeah, okay. So the next thing, because we can't see anything obvious about the mention of a security issue within the kind of the Git history and the project history itself, is we'll go request baskets 1.2.1 exploit POC on SSRF, POC of SSRF on request baskets. This vulnerability allows attackers to access network resources and sensitive information by exploiting the API basket's name. Okay, this sounds cool. So there's a GitHub project with this polished, I like that, polished shell script to demonstrate a proof of concept on this issue. It's been assigned a CVE, so it must be reasonably well disclosed and public. So let's just quickly look at the CVE. How does it work? Request Baskets is a web application built to collect and register requests on a specific route. So that's really just a path, so-called basket. When creating it, the user can specify another server to forward the request. The issue here is that the user can specify unintended services such as network closed applications. Interesting. So for example, let's suppose that the server requests, the server host request baskets port 55s, and a Flask web server on port 8000. The Flask is also configured only to interact with localhost. By creating a basket which forwards to localhost 8000, the attacker can access the before restricted Flask web service. So here you can see this is an actual example where they're running request baskets in a container, Docker container. Then they're spinning up their POC script. -v is the host that they want to hit. Proof of concept, etc. Okay, so this is how to actually replicate the whole thing, like set up an instance of request baskets and everything else. So we might just jump straight to the CVE, the proof of concept itself. Let's grab the repo and get a copy of it. Git clone that one. Okay, CVE, etc. So let's have a look at the script, shell script. Okay. Proof of concept of SSRF on request baskets. If arguments is less than 2, or argument 1 is -h, or argument 1 is help. That's going to spit this out, okay? So the URL is argument 1, attacker server is number 2. So this is the positional arguments when you run the script. $1 is referring to this, and $2 is referring to this. It's the bash positional variables. So if the URL, which is the baskets server, doesn't have a trailing slash, then it will add a trailing slash to the URL. That's nice, polished, yep. Basket name. So it's going to generate a random 6-character string using the letters A to Z to be the basket ID. Now, if we go back to here, you can see 1, 2, 3, 4, 5, 6, 7. Okay, doesn't quite add up. API URL. So along with the web interface, this request baskets I read in the README has an API as well. So let's find that. So it's under there's a RESTful API. So let's just do /API baskets. What was our basket name before? This one. Let's grab that. API baskets. Not getting anything back. 401. Permission denied. Okay. All right, I'm just fiddling around here, trying to figure stuff out. So it creates a new basket. Basket created. Accessing the basket URL now makes the server request to the attacker server. And it's going to capture the JWT token, it looks like. Well, sorry, the bearer token. All right, so we got a rough idea about how this works. Let's run it. So main path of the server is going to be HTTP IP 55555. Target. Now, this is why I kind of pointed this out in the beginning during our recon/enumeration, is that we've got these two services that we know are there, and Nmap has identified as filtered. So they're deliberately dropping packets to these two ports, 80 and 8338. Now, that's different to just having these services bound to the local host. So if these two services on 80 and 8338 were running on the CTF host, but they were only bound to 127.0.0.1, the local address, then you wouldn't necessarily need to filter or firewall off these ports. But I think they've done it deliberately as a bit of a hint that the nature of this particular exploit, where you can access network resources and do forwarding, essentially request forwarding. And the example they have is request baskets runs on 5.5s. And then you have another application on port 8000 that's configured only to interact with localhost. So I think they've deliberately filtered these ports so they show up in the recon, and to give you a hint about where to go next. So let's just try it. IP, let's just do 80. And if we go back to our instance here, do we have a new basket? But I would assume that we need to use this token. So we don't have JQ. Let's just quickly fix that. JQ is just a JSON query tool, I think is the acronym. But it's just so from a command line perspective, you can work with JSON. I'm surprised I don't actually have it. I thought I'd used it in the past. So what that would mean is if it's creating a new token, then we need to set this in our request, right? So how do we want to do that? I mean, we could do it through burp, or we could mess with our... No, it's going to be in the header, isn't it? All right, let's do this. Let's send it over to burp. Next. That way we can mess around with it a little bit more. I'm not a burp expert, but I need to get better with it. So we want to turn intercept on, and let's go back here and let's enable proxy, send it to burp. And the first thing we'll do is just try opening that. So we can see get web, blah, blah, blah. There's actually no authorization header. Oh, there it is. So the authorization call is in the API call, the subsequent API call. So the front end is making a request to /API baskets, etc. Okay. Forward. Whoops. Forward, 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 forward. Okay. So it makes, when this page loads, it makes multiple requests to the slash API baskets. And then that authorization token is present. So how do we want to do this? We want to take this basket ID. Let's take one of these requests. And send it to the repeater. We want to change the basket name to the one that our script generated, this one here. And we want to change the authorization header to be this. Looks weird though, this one's got multiple underscores. Okay, so we get 200, which means the basket is correct and the authorization is accepted. Like if we put an extra character in there, yeah, see we get 401. So that is validated. Let's just go back to the example here. So where does 8,000 figure into this? Oh, this is the service that you want to attack. Okay. That's the example that they're setting up. Okay, so I understand if you're testing locally. So here is your request baskets instance. Here is the POC code. They got this verbose switch. And you can see that when they run this, the internal service gets a ping. Okay, so how do we abuse it, basically? Okay, that's weird. Oh, it's because we're running everything through burp. Silly me. Disable. Yeah, okay. So what I'm just trying to piece together is what I understand is that the SSRF bypass lets you basically set, so like if I go in here and I go into the settings and I set this to 127.0.0.1 8,000 port 80. No. Forward URL. So where is the SSRF bypass? I mean, this looks like this payload looks like just a valid API requests. Accessing basket URL name makes the server request to attacker. Yeah, you see, it's going to complain because let's try this with -v. Curl option -v. Okay, -v is the switch. And this is a Python script. Okay. Like, I understand this in theory, but how do I actually use it to... Yeah, let's read a bit more about the exploit. Oh no, member only. Gotta hate that. Medium. No, we don't want to. We don't want to look at any write-ups. So it's just a one-time thing, right? Where does the actual... But where do I get the... How do I get the response back? Do I need to use the basket? Um, example. Request Baskets operates as a web application designed to collect and log incoming HTTP requests directed to specific endpoints known as baskets. Right, that's clear. During the creation of these baskets, users have the flexibility to specify alternative servers to which these requests should be forwarded. That's clear. The critical issue here lies in the fact that users can inadvertently specify services they shouldn't have access to, including those typically restricted within a network environment. Okay, so I think one of the problems that we're doing with this is we shouldn't be using the external interface. We should be using the internal interface. Okay. For example, considering, yeah, okay, that's straight from the README. This is the same exploit. Generate random basket name. Checks if the curl command was successful. If it wasn't, it outputs an error message and exits. Otherwise, it displays a success message and information about the created proxy basket. Okay. Okay, so it's kind of like at this point, we want to be like, how do we abuse this? So if we do curl, okay, this is where we run into some knowledge gaps. Curl, add header, minus h. So curl minus h. Oh, but that's index.html. So we want to take that out. And then we want to do curl minus h. We're going to add this token. Then we're going to add the URL. Ah. Okay, so then we grab the unique basket URL and make a request to it. Aha, okay. So now we get the... Okay, got it. So let's do this. So this is the HTML being returned by the internal service listening on localhost or 127.0.0.1 port 80. And yeah, this is what we need. So let's move this into burp. Get okay, first thing we do is we take this, we turn on, but then we capture this request. Yeah, then we send that to repeater. Then in here, we send. Does that work even without the header? Oh, that's the old one. No, that's the right one. Okay, so the last line is JavaScript. Yeah, okay. So this is the service that's listening on port 80. Let's just do some notes while we're here. Okay, we can get rid of this. Found for this version of request baskets allows us to reach forward HTTP requests using this exploit to internal services listening only on localhost from recon that is port 80 and 8338. Port 80 and 8338. So let's start a new thing. Port 80 internal slash localhost. Let's see what we can find. So straight away in the response for index.html, there's this mail trail header. So okay. Look, I might be screwing this up. So if we disable that and just go straight to the URL, yeah, mail trail. Now it's all messed up because I'm assuming that there's like all these absolute or relative links where, yeah, you see there's 404 for all the JavaScript and images and everything else, but we get the raw HTML for index. So let's just make some notes. Configured to redirect requests to port 80. And then let's do one for 8338. Okay, so now we've got this. Port 8338. 127.7.0.0.1. 127.0.0.1 port 80. So let's try this one. Looks to be the same. Mail trail. Okay. Let's fold these together because they're both serving up the same content. Not sure why, but whatever. Initial recon enum is running mail trail 0.53, was it? 0.53, yeah. Exploit question mark. We've already compromised one open source software package, so right. Let's grab the link for this because good practice is use this POC/exploit. No edits. Okay. Then 80. Yeah. Let's add this as well. So now we want to have a look around at mail trail. Like, what the hell is mail trail? Malicious traffic detection system. Again, pretty up to date. Commit 2 weeks ago. And releases 0.68. Let's have a look at all of them. 0.53, it seems like it's a long way behind. 5.9. When was this box released, by the way? 8th of July 23. Okay, so quite recent. 5.3. Start of month release. Then no real release notes, so we can't see, like I said, straight away. Oh, vulnerability. Vulnerability fixed from 0.53. So at least the version numbers match up with what we're seeing. So we know that we're looking at the right project, the right code base. Pretty cool logo there. And what does it do? Public blacklists. Okay, it's actually a cybersecurity blue team type tool. Containing malicious actors and or generally suspicious trails, along with static trails compiled from various AV reports. Okay, so it looks like it takes a whole bunch of open source intelligence, things like SQL map sets a user agent header that is very obvious. So here are all the blacklists that are being utilized, all the different feeds. Okay. Oh, this is cool. Malware command and control. So anytime that one of these blacklists or these feeds sees a command and control server in the wild for some malware, it gets listed here. Mailtrail is based on the traffic sensor server client architecture. Sensor is a standalone component running on the monitoring node. Linux platform connected passively to the span, mirroring port, or transparently inline on Linux bridge. So what that means is the sensor component or service, when listening via span or mirror, is able to see all the traffic going over that particular VLAN or LAN or network segment or whatever it is. Server's role is to store the event details. Front-end reporting is based on the FAT client. All data post-processing is being done inside the client's web browser. Okay, cool. I like this. I'm definitely going to look this stuff up later on. Mind you, it did have a, well, it may have a vulnerability, so let's have a look. Mail trail 0.53 exploit. Is it mail trail or mal trail? Oh, mal trail. Mal trail. MAL. Mal trail. Let's mal trail. That makes more sense now. Let's find the 0.53 release. Okay, there's the tag. And maltrail. Okay. RCE exploit for maltrail 0.53. Great! It's a security tool, but it has an RCE. Well, you know, happens to everyone, I guess, at some point. Developing software, it's very hard to, you know, continually develop software over, you know, a long period of time. Eventually, something is going to go wrong. Well, it doesn't always have to go wrong, but experience shows us that even the most careful software developers, you know, inadvertently introduce bugs that can be exploited. Username parameter of the login page doesn't properly sanitize the input, allowing the attacker to inject OS. Well, you know what? Like, I take back what I just said because that is pretty amateur, right? Now, I would expect that maltrail, if you're using it in your enterprise or whatever, it wouldn't be exposed to the internet, you know, so you wouldn't have this external threat of someone being able to compromise yes. But here's the thing, we've chained it together with this, or we're going to chain it together with this request baskets vulnerability, which lets us forward the request. Even though it's not listening on the internet, we can send a request to it. So not cool. The exploit creates a reverse shell payload character encoded in base64 to bypass potential protections like WAF, IPS, IDS, etc. Okay. So we need to give it a host, a port. This is the local host, local ports. This is where the reverse shell connects back to, and then the URL that we want to attack. Right, seems straightforward enough. Let's grab this. Okay. Let's go back. Git clone this one. Maltrail, not mail trail. Ugh, not too smart, Jono. Let's have a quick look at the exploit. Like I said, this one actually is probably more straightforward of an exploit than the one for request baskets, because unsanitized input. Oh yeah, super easy. So here's the payload, which is, it's going to run Python. This is basically our reverse shell, this payload. So it's going to use Python 3 to generate a reverse shell. And it's targeting /logins. Let's just check that we can get to that. So we're going to use this and then /login. Or maybe it's posting to that method. Yeah. Okay. So there's literally no like escape. Oh, okay, here's the escape. So username equals, that's the, you know, normal sane, the normal sane HTTP body post request. Then the encoded payload, which is a base64 encoded version of this string. and then they pipe it to base64 minus D, and then they pipe it to SH. Okay. All right. That's, look, as far as exploits go, that's about as straightforward as it gets. So first things first, let's start up a listener. NC NVLP, and then we're going to do Python 3 exploit.py. What's the listing IP, listing port, target URL? Listing IP is going to be 10, 10, 14, 44, 1, 3, 3, 7, and then our forwarding URL, it's going to be this, http:// oops, we kind of mangled that. There it is. Okay. So we got the reverse connection, the reverse shell back. Let's make this a bit bigger. ID. So we are running as user Puma, group Puma, any other groups? Nope. Okay, let's make some notes while we're here. Available pre-auth RCE with reverse shell. And that is going to be from here. Oops. Okay. Using Maltrail 0.53 exploit, we have a rev shell with UID 1001 Puma. Okay, so we're not a privileged user or anything like that. Let's have a look at other users on the box. We got underscore Laurel, who doesn't have a shell. So we got root SSHD. No, that's not actually a shell. Yeah, so Puma and root are the only ones with an interactive shell. Which directory are we in? Okay. Home, Puma. Let's grab the user flag and let's file that carefully away. And now we need to privask. So let's make some notes. Unpriv user, or regular user. Run keys for privask. We could do that. Let's see. So we've done that. Let's do sudo minus L. Oh, okay. So no password required. So it lets us sudo user bin system ctl status trail.service. Yeah. And that's the actual application service that we're running as. So the service itself runs python3 server.py. These are all the processes for our user. You can see our rev shell process there. Okay, so how can we mess with this? Oops. So I know that this is bad, as in it's a misconfiguration, right? But I'm just trying to think how we can abuse it. I think we will have to turn to our old friend Hacktricks and sudo. I'm just trying to think, like, because we can only run systemctl. We can only run systemctl status. It's not like we can restart the service. So can we actually edit the service file? Which is going to be etc systemd system_trail.service. So this is the file that defines what commands are run when the service is stopped and started. So vi etc systemd what was it? Trail.service? Nope. System vim or vi trail.service. Yeah, so when it starts, it moves into this working directory. It runs python server.py and it'll be restarted on failure. So maybe we can edit server.py. But it's running. Oh, goodness. It's running trail.service. It's running as the user that we're currently logged in as. So there's no privesc there, in the sense that if we were to edit this, it's still going to be running as the Puma user. So the abuse, like if we do ls minus lath opt, what was it, mail trail? Oh no, it's owned by root. But then if we do psaux, psux, yeah, you see there's the actual service itself. So it would only start as Puma, and to be honest, we can't edit those files anyway because opt, mal, trail, we can't edit them anyway because they're owned by root. User group world, yeah, we only have read access. Okay, let's think about this. So let's try and find a specific example. So use sudo systemctl. I don't know, there's got to be some like way to inject something somewhere. Haven't tried this either. Not that I expect it to work. Yeah. We don't have the password because we're in a reverse shell. Yeah. Okay. You can see the path used by systemd. Yeah, but again, the arguments are specific. So we can't do systemctl stop trail.service, for example. Sudo systemctl stop trail, or let's do restart trail.service. Yeah, it's going to prompt us for a password. Okay, so I kind of know where to exploit. I just don't know how. I'm sure I've come across this problem before. I just cannot remember how to do it. Priv esc sudo systemctl. So that's assuming you've got sudo access to systemctl, but we've got like this specific restart specific service. Because if we had just raw systemctl, we could create a new service. Yeah, exactly. We could create a new service to give us a payload, etc. To give us a reverse shell as root. Yeah. Oh, here we go. Spawn shell in the pager. Okay, so without reading too much further, if we do systemctl status, it's called trail.service. Yeah, see this? The pager. The pager is what system CTL is outputting itself to. And there it is. So this is a top to bottom list. This is the newest PID. This is the oldest process ID. So pager. Oh, goodness gracious. Killed it. So let's just get another window going. Pager. Man pager. So pager is just an alias for less. And what it's telling us is that because systemctl invokes less when you run the systemctl status, is that we can spawn a shell via less. Oh, it's that simple. You just issue the command bang sh. Like, yeah, I suppose. Okay, so say systemctl status just flushed the output straight to your TTY, then it wouldn't be vulnerable. But because this command is running as root, it's invoking less, and from less you can spawn a shell. I didn't even think of it. Sudo system CTL status trail dot service, and then we go bang sh. Hey, there we go. Whew. Okay, so let's get the key while we're here. That was really obvious in hindsight, but you live and you learn. All right, that box has been pwned. Boom. Okay, cool. Hey, what happened? Oh, flag difficulty. Okay. Why didn't it give me... Oh, I never submitted the user flag. Okay, give me the box pwned. Yay, there we go. Sau has been pwned. So, look, really, really fun. I gotta say, that was beautiful. Priv-esque was achieved because we had passwordless sudo access to systemctl status command. This command is invoked as root via sudo. It outputs to less or pager alias. Within less / pager, you can easily invoke a shell with command bang sh. Cool. Yeah, that was a lot of fun. I really, really enjoyed that. So chaining together two different vulnerabilities, open source projects. Look, at the very least, I like request baskets. I like Maltrail. I'm definitely going to, look at them for use in, my other kind of day job and experiments and other stuff that I do. So really happy about that. But I like the way it came together. So we had external access to ports 5.5s, which was request baskets. The Nmap response with port 80 being explicitly returned as a filtered port was important. So normally, like when we do recon and enum, it's like, yeah, filtered, whatever, okay? Like, because we're trying to attack these services that are open. But that little piece of knowledge that kind of stuck out during the recon phase really helped kind of guide me through it, because once I saw the type of exploit that existed for request baskets, i.e. being able to forward a request to another host, to another internal address. And I'm assuming that normally they would filter out 127.0.0.1, which is why the SSRF bypass was needed. Yeah, that, and then that kind of got us access to this. The reverse shell for Maltrail was really straightforward. It was a bad validation on the login parameter for the post form. So we're able to really easily take advantage of that and get a reverse shell via that service, which isn't even exposed to the internet, right? Like, we didn't have to SSH tunnel or anything like that. We were able to effectively use request basket as our proxy to the internal service. And then it just goes to show that having that checklist, once you do have an unprivileged user, of just being able to, issue a whole bunch of commands and, basic stuff to go through. And one of them now for me is always sudo -l, because I've missed that in the past, and I've tried to do privilege escalation through all these complicated means. But if I just looked at the sudo config, I would have seen straight away there was a vector there. And then the vector with this command was that, as we just outlined, it pipes its output to the pager alias, and in this case it's configured for less. From less we can spawn a shell, therefore we inherit the context of this sudo command. And that gave us root. Wow, lots of fun. Really, really enjoyed that. If you're stuck around to the end of this video, thanks very much, and have a great morning or night or evening or whatever time it is for you. I do appreciate the comments and the likes and subscriptions and everything else. So thank you to everyone who's hit those various buttons and made the algorithm go burr. Yeah, it's been awesome. Really, really enjoying it, and hope to see you in the next video. Cheers. Bye-bye.